Today we're picking back up with site design. We're going to talk a little bit about pavement and just about general layouts in site design, which is often left up to the civil engineer involved in these site design projects to work on. The architects usually confine themselves to the building pieces on that, and there's some back and forth on it. But as far as the actual final design pieces, a lot of times that's left up to the engineer in a job, which could be you. It could be in the future. Sometimes landscape architects get heavily involved in it, but that's usually closer to the building where they're trying to make pretty stuff. Once you get out far enough, it's just parking lots and sidewalks, they leave it alone. It's all just us at that point. One thing to talk about pavements, this comes up a lot during senior design, is what pavement depths should you use for parking lots? And I just had a couple students ask about that in the senior group, and looking at should we use easel calculations, and should we use those big long equations to calculate our pavement depths? And the answer is no. That's I mean, think about how many easels do you think a parking lot gets in its lifetime versus a road, right? Just even a busier parking lot, right? It's going to be a lot less traffic than a road has, and it's quite often very few trucks in a parking lot. So if like your medical office building, you're going to get an occasional truck come through there for a delivery, and it's probably going to be a smaller one. Okay, yeah, lots of UPS trucks and FedEx and Amazon, but probably no WB67s coming through there. If there are any, if it's that big of a medical complex, they usually have a loading area on the back side. All right, so in the front area where the patients will come in and so forth, that's going to be very light residential and just going to be passenger vehicles generally, right? And we've already learned that a truck has 5,000 times as many easel as a car does, right? And so that's you're going to get so few easels in a parking lot. That's not usually the issue, right? In fact, we went through a project again like about a month ago. Their easel calculations and their structural number were so low, it was almost impossible to figure out a pavement for that. I think it required like a 2 or 2.5 inches is all it would need based on strength of the pavement. And so we'll talk about that in a second. That's not what controls, right? Now, an industrial site, if you've got a Walmart and the loading path where trucks coming in and out, yes, that will need to be a beefier pavement section. If your site development is for a concrete plant, okay, that's going to be one heck of a pavement there, right? And those loaded concrete trucks coming in and out and aggregate hauling and all that going on. So it depends. Industrial sites, yes, they may have a significant number of truck traffic, but even then, quite often you separate the truck loading and unloading area and have its own access and its own turnaround area and all that. And there would be a separate parking lot for like employees and so forth. So not all of that pavement needs to be beefy. If it's just general light vehicles, it's not beefy at all. Right? So just keep that in mind. Just thinking about it, what your use is, but generally most of these site developments, you're not going to get much truck traffic, or only if you do, it's only in certain spots. So just as a reference to get started about what would you consider starting point for pavement on this is, let's look at these driveways, these approaches that we looked at from INDOT last time. All right, so what is that? What kind of pavement are they using for that? All right, and what we find in our sites, like it says over here, what usually controls is what's the minimum pavement section you can have for to hold the material together. It's a material problem and a construction problem. It's not a strength problem for that. What I mean by that is in an asphalt pavement, right? If you've got half-inch aggregate in there, right, you probably don't want, let's say if you got a 1-inch diameter aggregate, you can't do a 1-inch thick pavement layer, right? Your rocks will be sticking out of it. That's just unworkable. You aren't going to be able to get that. And like surface mix, we usually use a 1/4 inch. And so you can use, thinner pavements that way because you have a smaller aggregate size. What it turns out to be is that contractors are really bad at, we get down to 1 inch, their paver is just not accurate enough to keep that inch depth. And you're going to have shallow spots, you're going to have deep spots. It's just not going to be great. We used to try it. It didn't work. All right, so 1.5 inches is your minimum pavement depth for a surface mix, and that's just what it is, right? It doesn't matter if your structural number says you only needed a half inch. Well, you can't get a half inch of pavement. You're going to get an inch and a half, because that's what we can place consistently and with good quality, and so forth. And control the grade on it is really the most important piece. And what we look at there is, that maximum aggregate size. We want, the total pavement depth to be 2 or 3 times that maximum aggregate size, so we can pack it all in there nicely and have a good mix of a range of sizes in that, and we don't have lumpy asphalt, with rock sticking out of it. That's not good, right? And we'd probably want to be more towards the 3-inch, right? So for an intermediate surface, which usually has larger aggregate in it, you're going to probably design that. That's like easy a 3/4 inch aggregate. Top size in there. It could be bigger, but that's often what we use. You're looking at about 2.5 inches is probably your minimum. Yeah, you might be able to squeak by a 2-inch lift if you use a smaller aggregate, a half-inch aggregate, but it's probably going to be more like the 2.5 inch. So that really comes down to that's what our minimum size usually is just that. It's not strength. In concrete, what you have to worry about there is thermal cracking. Right? If your concrete pavement is too thin, it's going to buckle and it's going to warp and crack, right? And that's a serious problem. So you need a certain depth of concrete to just be structurally stable just on its own, even without cars driving on it. And again, it's not going to be the strength issue of the weight of the cars driving across it. It's going to be its own internal forces. It has to balance all that. And if you're going to put some wire weave in there to keep the thermal cracking down, right, you need you have a minimum depth of cover so that it doesn't corrode from the salt from the road and so forth. All these things set up that minimum depth, and so that's what controls. In this case, it's not the strength of the pavements. So remember that next year when you're taking senior design. So this was from this is that approach diagram from NDOT, and the approach is where you've got a parking lot and you're like, well, how deep should the parking lot pavement be? Well, the approach is the worst situation, right? You've got all of the cars who are entering and exiting your site, entering by 1 or 2 or maybe 3 entrances, but this is where the concentrated traffic is, right? If anything is going to fail, it's going to be these approaches first, and this is what is tested and true. Pavement depth works for that, and this is a residential driveway, so it's a little bit less, right, for there. So we're going to look at this as kind of the worst case, and this is what NDOT's using: 165 pounds per square yard HMA on 275 on the intermediate, right, for that, or 6 inches of concrete. And I've seen people use less concrete. 6 is good for the approach. You might be able to get away with a little bit less out in the parking lot. Through there, if you remember the conversion factors, it's 110 pounds per square yard per inch depth of HMA. So 165 pounds per square yard is an inch and a half. 275 is 2.5 inches, right, of depth for that. So just keep that in mind. That's if you add those together, that's 4 inches. That's all the asphalt we're using, and that's a residential drive. But these tend to be a little bit overbuilt. NDOT likes to overbuild stuff, and it's on really good aggregate, right? And that's actually where you pick up a lot of strength. For one thing, you've got a good drainage layer there, and that adds a lot of good strength to it. So you not only got 6 inches of ag under it, but you've also over compacted that subgrade, so it's very nice and consolidated for you before you put the aggregate on, which you compact again, and then you put 4 inches of asphalt. All right, so it works together as a piece, and it is, so that's 10 inches total of active depth. I guess that's how much you'd have to excavate before you put this in, right? 10 inches down at least for that. And in the concrete, same story. You've got 6 inches, but you also want to do either a dense graded subgrade, or you're going to do a subgrade treatment, which sometimes is just throwing more aggregate in, right? So that's quite a bit of aggregate. It's not uncommon to see a parking lot is just 4 inches total, right? I'd say, if you want to be a little conservative, I'd go 4.5, probably out in a light duty parking lot that doesn't have trucks, right? 4.5 on good aggregate and well compacted subgrade, right? Then you're probably good on that. And probably 6 inches is where you'd want to be with Portland cement concrete pavement. And if you like the white stuff, better for that, right? On a commercial drive, this is what NDOT says for up to 400 trucks per day. That's a lot of trucks, coming into a business, right? It's and they say trucks. I think they mean fully legal weight limit trucks coming in and out for there. 400 per day. Think about that. That's a lot of trucks. What kind of a business needs 400 trucks a day? Amazon factories or warehouses, not factories, I guess. They aren't making the stuff there. Amazon warehouses need 400 trucks a day. And probably more. So you'd actually design that you would probably design like a true road. You would do the analysis because that's a lot of trucks, coming in and out of that. The concrete plant, sure, you're going to design that like a real road for that. But 400 trucks a day is going to cover almost everything else. Even the UPS distribution warehouses don't have 400 trucks a day, right? They literally, well, at least one here in town, they literally have like 6 semis and then a whole bunch, they're little trucks, which don't count for that, and much lighter right through there. So that's all they have, and that's hauling all those packages in and out of a local distribution center. Right? Walmart does not have 400 trucks a day. Right? Walmart may have 5 or 6 trucks a day, if I had to guess. I don't know. I just made that up. So take that for what it's worth. And in this case, what they're going with is 10 inches of HMA. So here we've got the 1.5 inches, 2.5 inches on 6 inches of base now. We didn't have that before. And then still put that all on top of nice aggregate and maybe throw some geogrid under it. Geogrid's good stuff. It really holds things together nice and keeps you from having soft spots in it. Or you could go 9 inches of concrete, right? And you may think, well, before, we had 4.5 inches of HMA and 6 inches of concrete. We needed more concrete. And now suddenly we need more HMA than we need concrete. Well, this is this minimum size, right? You don't want to get below 6 inches, probably, if you're going to do a good job. You don't want to get below 6 on a concrete pavement. Yeah, you might sneak 5, but it's going to generally be 6. And a lot of it is that if you've got that wire mesh in the middle, you want to have over 1.5 inches and probably more like 2 of cover, so that it keeps the chloride from seeping through and attacking it right through there. These are the hard limits of what you can reasonably build and will hold together nicely under traffic. It's not by strength. Now this is getting into strength design, right? So you don't need as much concrete in this case. So great, but concrete's more expensive than asphalt almost always, especially right now. So you're gonna be better off with the 10 inches of HMA, right, for this. So this is actually probably a little closer to actually becoming somewhat structural in your depth. And this is a commercial entrance, right? These are commercial entrances with up to 400 trucks. Okay, just keep that in mind. All right, big stuff. So that's so when someone asks you next year in senior design, how do I design my pavement? I don't know. Should I use the AASHTO equation? No. No. Just go back to these notes. You find some minimum and use it. I mean, literally when I was in site design, we just always use the same pavement section on every building. I think we just, like this library was from the same company. We probably use the exact same pavement section. Look, this is 20 years old. This pavement looks great, right? It's been treated at least once. You've had at least one surface treatment, putting asphalt on it, and you can see where cars are already rubbing it off again. But yeah, you do a little bit of preventive maintenance. This stuff will last quite a long time because it doesn't have that truck traffic on it. Right. We'll talk about in a second where the truck traffic may be on a site like this one, on this particular site. Right. So let's talk about flow. Today we're talking about flow, and no, not drainage yet. Not drainage yet. I'm waiting. A friend of mine is supposed to send me some plans. We may do some drainage site design stuff if I get them in time. Otherwise, we're moving on to traffic calming next time. But for now, we're going to look back last day, maybe if I don't get the plans on doing site design stuff. But what I'm talking about flow this time is think about how this works, right? So this is kind of big picture stuff, more fun theoretical things, right? How does your site work? And again, architects are going to have an idea about how they think it's going to flow, and they'll say, yeah, it needs to have a canopy, and the owner may say it has to have a canopy and a drop-off area and all that. And the landscape architects go nuts down here, all around the building. This is taken during the fall or spring, so you don't have that nice pretty green stuff all over. And you can see there's a lot of trees out here, right? They spent a lot of effort in this landscaping, which we can't see very well from this picture. For that, but once you get very far from the building, if you're out here, this is the civil engineer's territory. They're just gonna say, oh, I need 14, or in this case, like 41 parking spaces. Actually, you calculate that, and if you take the 457 class, you'll learn how to calculate that. So you'll figure out how many parking spaces you need. Well, actually, we did it in this class already too, a little bit, and so forth. But they're going to leave you alone when you get out here. Generally, right? They may say, well, They may ask you to put a wiggle in the road because that looks cute or something like that. But then they're going to leave you alone, and it's up to you to make it work, right? And pretty is nice, but it's not required. Yeah, functional is what you need, right? So think about the flow, right? And this may be your thing. And as you're laying this out, as you're asked to do this as the site designer in the civil side, do all these functions work? And so one is, how are you going to get people into this building? How are they getting into the building? And yes, in reverse, how they get out. But if you solve it in one direction, you almost always solve it in the other direction, right? So how's that working? How are you getting vehicles on and off the site? How is the traffic flow, which is different than the pedestrian flow, right? For that. So that's another, we'll look at that coming up. So again, things to keep in the back of your mind as you're laying this out. I've seen, again, from 3 years of senior design reviews, that sometimes people's early versions of the parking lot have no way for people to get through the parking lot up to the building, right? They just have a huge parking lot. They don't even put sidewalks in, right? So now you know not to do that next year. Keep in mind all of the possible routes, right? What's the flow? How are people getting from where they're starting to where they need to go? Right, through that. And then finally, vehicles enter the site, but then they convert into PEDs, right? So a vehicle enters and it converts into a pedestrian. Once they leave the car, how are they getting into the building, right? And is it safe? That's always in the back of our mind too. Is it a good access route? Does it make sense? And is it safe? All right, for you there. And we're going to talk about that in more depth as we go through here. Let's start out with PEDs, right? So we need a clear, safe path. Let's start with PEDs. Where are the PEDs coming from? So let's look at this site design, right? And we've got sidewalks. Now, this one doesn't connect anything, but they were hopeful in the future someone would extend the sidewalk. But if this was a more urban environment, yes, the people are going to be out here on the sidewalk. This is inside of a subdivision. There are definitely people on this sidewalk. Yeah, this extends all the way through the subdivision. I didn't give you a big enough picture to see the rest of the subdivision, but take my word for it. This is a well-populated subdivision. Build out lots of duplexes and stuff. There's a little bit higher density. And people were going to walk to this library. This was the main amenity added to this site to improve the sales of these houses. So people would want to live there. All right, so we start out here. We start out here at this sidewalk, or we starting here at this sidewalk, and let's think about how people are getting in. Right, they're going to follow the sidewalks. They did a nice job, right? We have a clear, delineated path all the way up. We cross the parking lot, and then you go into the building. You have to cross some traffic once again, under the canopy, and there you go. If you came in from this sidewalk and get entering from off-site, you come across. You cross one driveway. You cross another driveway, and then you're in the building. All right, so you've got pretty clear, well delineated. Let's back up so that those aren't on there. We start out here in the red zone, which is where the PEDs are, and how are they getting in? Look, we got a nice. They did a pretty good job, right? Pretty good job of, you can see where the likely path is for people to get. It's clear. You want to make things clear for people so they aren't confused about which path should I be on, right? It's pretty clear. These are both leading you right to the front door, and the front door is right here in the canopy. All right, so they're both leading you up to the front door. So good job, right? They did that. And kind of went crazy with the digital pen, right? It works a lot better when I'm not doing it live. It writes perfectly fine, never does that little jaggy stuff. So it must be something about presenting that makes it do that. I don't know. They have good, well-defined paths coming in. The negative, which isn't a huge negative here because this happens almost all sites, is you've got these crossing zones, right? And this one's kind of big. This is kind of a wide open stretch, hold your breath and run, but there's not that much traffic, right? So it's probably not that bad. And these are pretty short crossings, and also again very low traffic. I think they bring the bookmobile in here on this one, and this is the employee entrance over here. Maybe a drop off, maybe a book drop off over here as well, but generally it's pretty low volume through that. You can see here, you can see where the pavement marks are. This one's a little bit higher volume. People are coming around and coming back through. You can see very high movement there. This is Kern Road. This is the bigger road. They don't have an entrance on Miami, which has even more traffic. But Kern is fairly busy road, and it connects all the way across the county there on the south side of South Bend. It's going to bring in quite a bit of traffic. You can see that's the main movement, right? There's not that much coming in from the subdivision. Okay. I think they did a pretty good job. I'd give them a B+ on that. All right, through there. How about PEDs? Or yeah, vehicles. How we just did PEDs. How about vehicles? How are we going to get vehicles in? All right. Well, pretty obvious. We're starting down here at the two roads, up here on Kern and down here on this subdivision road. They flow in, and then they're going to choose a side to go to. This one flows in. You got a three-way decision point. Coming through here. Now also there would be some exiting traffic this direction, but this is one way. They got arrows in here. So you can only go this direction through that, so you don't have to worry about oncoming traffic here. All right, so that's our vehicles are flowing in. Is it clear and consistent? Yeah, pretty much. And you can move on down through here. You can find your parking spaces. Great. All right, you can flow through, drop off somebody here under the canopy if it's raining or snowing, and come back around and now find parking. Right, and it seems to be pretty decent flow. Right, so we've got clear flow paths. Should be pretty obvious where you're going. Now, the only downside is if you're new, if you haven't been here before, you come in this one, it may not be completely obvious when you're here that this road will take you right up under the canopy. Maybe you don't want to go under the canopy, it scares you, and you wanted to find parking. Okay, well, you have to jag over here to get to the parking. Right, okay, so but pretty good, right? Are there conflict areas? Are there traffic conflict areas? There's going to be a little bit here. These people are coming in and they may want to wiggle over here, but someone may be going out at the same time. Do that. So is it clear who's got the right of way there? It's probably such a little traffic. It's not a big deal, but keep that in mind. Okay, there could be some flow conflict there. There could be some here. People are, excuse me, are circulating here. They're probably some of them want to go back out to Kern because that's the big road. And they don't want to go through the subdivision. So they're going to curve here and come down. And if someone's coming in, they're going to have to pause and wait and try to figure out who has the right of way through there. There may not. It doesn't look like there's signs in there. I don't know if there are or not through that. So that could be another possible conflict point. And then you've got incoming people versus outgoing people trying to find parking, but that's pretty standard. No big deal there. Not bad. All right. Do the unfamiliar people, or do they understand where they're going to go? It's pretty clear. I think it's pretty clear. If you came in from this side, you'd know, okay, here's all the parking, right? I use this park and I can walk in. We're ready to go. All right. And one other thing we want to keep in mind, and it kind of tied into the PEDs too, is we want to minimize the amount of vehicle interaction with pedestrians. And so, again, from the vehicle driver standpoint, can we reduce these spaces where the PEDs are crossing? And this one doesn't even have a crosswalk marked. Some of their newer buildings did, I think, but this one didn't. And again, the one downside here is they are directing canopy cars right across the main pedestrian access route going into it. So, but this is low speed. People are aware there could be pedestrians that are going to be going slower. It's a slight ding, right? We'll give them a small ding on that one. So try to control those pedestrian interactions. And in a library situation, it's not as big an issue. A Walmart situation, it's a huge issue, right? And they don't, I think they gave up. They just always put the driveway right out in front of their doors, right? And then you're always interacting with PEDs. So more forward-thinking people have tried to move kind of like this a little bit, is that once you park, you don't have to cross any access roads again. So if we didn't have this route in here, this would be a pretty safe one. You could park here and you'd never cross with cars again, right? And then our final piece is, if you park your car, how are you going to get into the building, right? So I like to do, it's kind of like the same thing I do with drainage, right? If water hits here, where does it go? If water hits this point, where does it run? If water hits this point, where does it run? That's how you check. That's how I check my designs, is you can pick any point, and do I know where that water is going, and does it have enough grade or too much grade, so forth and so on. So you should be able to just kind of like drop a water balloon at any point and know where that water was going to go. And maybe it's, a big lawn like this, it's okay to be flat, but you want to know what it's doing and that it's not going in the wrong direction. And if you need to keep it moving, you need to keep it moving. On a parking lot with drainage design, you drop, the water balloon. Where is that water running? You do that in your head all the time when you're designing these, to make sure that you don't have a flat spot somewhere you've missed. All right, we put elevation points, at these corners usually of the parking areas, and then we don't put much else out in the middle, but internally you got to think about, well, is it really graded all the way across there? Is it straight graded? Do I need to do something to add in a low spotter and a drain? We do the same thing with cars. that's where I was going with that. We would do the same thing with cars is if anywhere you park, how is that driver and passengers and, and this is a library, right? So it could be small kids. How are they going to get in the library? What's their path, right? So I park here, I'm going to walk in here. Okay. Yep. That seems to work. I have to cross the parking lot. We're used to that. And then I hit a sidewalk. Everything's great. Park here. Yep. I can get in here. Great. I'm right at the sidewalk, follow the sidewalk around. Okay. It's great. Right. It's very good. So you want to make sure that no matter where you're at, there's a fairly reasonable and safe route to get in from there. And you assume drivers, especially around here, are used to navigating some traffic in the parking lot, right? We're used to going to the big malls and Walmarts, and we'll park out and have to walk through the parking lot in the aisles. And we do it safely, fairly reasonably, quite often, right, for there. But once we get near the building, we want to have a good dedicated route. So they did a good job on that, I think. So we're taking that into account. And you should be able to point to any parking spot and say, yeah, there is a good route. Like a reasonable enough route coming in. That's the idea of flow, where it involves former occupants of vehicles, right, from that. And then our last piece connected to that are, how about our ADA spots, right? These are wheelchair accessible, and older people who need a nice, level, easy way to get into the building. And so one thing we're looking at here is, and they did a good job, we've got them isolated so they're all in the same spot. It's easy to find them, right? So once you come in, like, oh, here they are. They're all right there. They're close to the door. That's almost as close as you could get. The nice thing is here, you don't have to cross, and that cross traffic coming through here. You have a dedicated path, and there is no playing games with cars to get in, right? You've got a clear path that's dedicated to you as a pedestrian. And that's a good thing, especially some of these people are elderly and are going to move really slow. Crossing these paths is a little scary for them, and it takes them a really long time. So they're out in the open, I guess you could say, open to some danger, much longer than younger people. You'd be crossing that. Right. So yeah, pretty good job in your site design. So keep that in mind. That's one of the first things you usually think about as you start laying out your parking lot is, where am I going to put the ADA parking for that? And sometimes we'll split it up. We'll put some here and some there if it's about equal into the building. I think this is a pretty good design. Putting it all over here. It's all located, and particularly because it has this dedicated spot, right? That's the only place you can park and go straight into the building without crossing traffic, assuming you use your little these little landing zones there, the marked off spots. So I think they did pretty good job on that. So that's the flow. So that's thinking of all of the users and how they're getting in and out of the building. Now, if this was a commercial site, now we would think about trucks. If this was our delivery area and we're going to have big trucks, where do the big trucks come in? Do they have adequate space? Can they turn around? How do they interfere or not with other traffic and with pedestrians, right? And you, as you can see, right, we often put loading docks in the back so it stays away from general users and particularly pedestrians, right? So what else? How about employees? Where are employees parking? Right? How about deliveries? So the library's got deliveries too, not large deliveries, but it has deliveries. And trash. You may not have thought of that. Where you put your dumpsters is a big deal because the rest of this parking lot, right, we're saying it's all cars, maybe a UPS truck now and then FedEx. But you've got once a week or twice, you've got a trash truck coming in here. Can a trash truck get to the dumpster and pick it up and everything works? So that's, it's non-trivial. Where you put and you have by most design standards, you have to have a pad for it, and you've got to put a little partial wall around it to block the view of it. That's under design standards for most jurisdictions now, that's required. And I think it was in this case too. So employees, then they're back here. This is the employee parking lot. This was the employee entrance over here on this side. And so they've got their own little dedicated spot. I can see a light post here, so it's well lit. That's important for employees and for everybody, but particularly employees because they may be closing up late at night by themselves, right? Or coming in early in the morning. And it's close to the building. It's easy to get in. They have their own little access coming in through here. Right. And they stay out of the main mix. It's, I don't know, just a nicer way to control kind of the usage on the site. For that's a pretty good place for it. Sometimes you don't have a particular employee lot. You just let them park out with everybody else. That's the Walmart system. for there. Sorry, Walmart, I keep dissing on you. Deliveries, we talked about that. Well, if you had deliveries, you could look for a special location for that. This is the dumpster area, and actually this is like a transformer, and this is their probably their big gas meter. This is the utility section. It's all back hidden here in the corner, and they got a little wall around it. For that, the garbage truck's gonna have to pull up here and get the dumpster, and then quite often they have to back up. Right, and so and they are used to that. They're not adverse to it, but you can't have a big sharp bend. I think this looks like the dumpster right there. I think it's got pulled out because that dumpster truck, that's not the right, the garbage truck doesn't want to come up here and turn hard right and then get to the dumpster because he may not have a good enough turning radius and couldn't line up well. So quite often we'll set these at an angle so there's a nice straight shot for the garbage truck to come up there and be able to pick up that dumpster and dump it. Right, because they're all automatic now. They, obviously, used to be they'd back up to it and you took a winch with a cable on it and dump the dumpster that way, and you could roll them out. The guy had to get out of the truck and roll them out. Well, no one gets out of trucks anymore. Not those guys. They're in a hurry. So the dumpster has to be lined up for them. They come in, they grab it, and then they go again. Right. Think of the one behind Gellerson. Right. They have to open those little doors, but it's pretty lined up, nice straight shot for the dump truck to come straight in. Not a dump truck, garbage truck, to come straight in and grab it for there. So those are all big things to keep in mind, and well, maybe some little things in there when you're laying out site design for that. Just again, just trying to give you some general pieces of it. I'm waiting on, like I say, hopefully some nice design plans from Marsh. They do a lot of site design work in northern Indiana, and that's kind of their specialty on that. So a fellow I knew in the past, he was going to try to send me some, as long as the owners sign off and allow us to look at them, we'll probably dig into how we actually do the grading, how we show it on that, right? And I think it's kind of fun, honestly. It's always like a puzzle, right? It's like doing Sudoku. Engineering's a lot like that, right? You know what the elevation of the floor is here in the building, and you have to get people out here to the parking lot, which is a lower elevation probably, but it can't be too steep, but it has to be steep enough to keep water moving, and you got to show enough elevations to show everybody how to build it and so forth. So it's kind of interesting, and it's kind of involved. You can take quite a bit of time to do a good job on those site plans. And I think showing some examples and working through some of those would be really useful for you guys thinking about, what your future work may look like. Where we've done quite a bit on the roadway side, and you've seen some roadway plans. We haven't seen site design plans yet. It's a little different animal, and don't think that site design is easier. It's not. It's not. Road plans can often be much bigger projects, so there's more work that way because they go on much farther and they have their own issues and pinch points, I guess, things that you really have to be careful about on them. Site design, even though a site like this, right, doesn't look that big, right, just doing the grading plan on this is probably more than a week if you did it right. For that, at least, well, maybe I wasn't doing it right. But when I would do site designs, about this size, it takes quite a long time, right? You're going to iterate through this, and then you think you've got it all solved, like you'll solve this part, and then you suddenly realize that you've got a 7% grade on the sidewalk over here. Can't have that, so you have to redesign everything and get it right. For that. So they can be very tricky, right? Don't be misled by small sites. Small site on a steep grade, like if you were out someplace with rolling hills or mountainous, they can be even worse. They're much worse. Trying to keep grades below a certain level, right, and have good access paths for both cars and pedestrians, right? It can be really complicated. In Indiana, our bigger problem is that everything's too flat. We can't get drainage going where we need it to. So next time we'll try to get that. If not, we'll be doing traffic calming. It's kind of an interesting subject, a little bit on the side on the highway design. But how do we design roads to, I guess, how they're built to keep speeds down? Just like a roundabout, it's the geometrics that keep the speeds down. We can do other tricks to keep car speeds down on other roads. And again, we're more in urban design. That's often asked for, right? People are cutting through a neighborhood really fast. Can you do something? Well, yeah, we can. We've got some tools, so we're going to try to go over that. That may take 1 or 2 days for that. Then I'm also waiting on a little guest lecture, hopefully someone will record, for me on railroads. And that'll be where we'll be finishing up, is in the railroad piece. All right, we'll see you next time.